lasers come out of the side of the machine there, and you do a scan. You do a horizontal scan, and then you do a vertical scan. And the software integrates the two. It's actually the data processing with 21 million data points per second is obviously enormous. So this is some of the things we look at when we're measuring trees for carbon. We look at the area that we are considering in our scan. You'll see that's roughly 1/2 hectare. Having done the scan, we can then work out how many trees we have, almost 600. We can convert that to a number of trees per hectare, and then we end up with a volume. Now that volume is generated from the obviously the code and the processing of the unit after the field work. And there's a few key rules of thumb here and assumptions that can be important for you to remember in relation to carbon accounting. And that is that the weight of trees is influenced by its water content. So there's wood's roughly 20% water. And then we have to also have a subsoil tree component. There's a roots component to carbon, and that's roughly 20% of the assumptions in FullCAM. This is a really critical one. The carbon content of dry wood is roughly 50%, so 0.5. That means that once you've removed the water from wood, if you weigh that wood and have oven dry weight, then roughly 50% of that oven dry weight is actual carbon. And that's what FullCAM is calculating, is the tons of carbon. And then we use a factor of carbon to carbon dioxide, which is 3.67. And this refers to the relative atomic weights of carbon and carbon dioxide. So the atomic weight of carbon is 12. The atomic weight of carbon dioxide is 44, because it's 1 unit of carbon at 12, plus 2 units of oxygen, which each have an atomic weight of 16 each. So 16 by 2 is 32, plus the carbon is 44, and the ratio of carbon to carbon dioxide, 44/12, is 3.67. So that's how you can calculate, as a rule of thumb, carbon anywhere you are. If you know the volume of wood, you can remove an assumption for water. You can assume how much is under the ground. You divide the weight, the estimated weight of the wood by half. And the key component there is knowing the basic density of trees. And this is where it can get a little bit confusing. So how do we go from volume to weight? We use what's called basic density converter. And that is where different tree species have been measured over time, and we know their specific gravity. I'm not going to go into that today. That's fairly technical. So this particular method resulted for this site in sorry, we had a quick technical glitch there. So just going back, after you've done your conversion of carbon to carbon dioxide by multiplying by 3.67, we end up with an above ground biomass estimation in this particular case, of just under 650 tonnes per hectare. And then the complete drawdown equivalent of the surveyed forest, including the root systems, is 1,190 tonnes of carbon dioxide. This is this particular example. So these are some very important links here. I mean, this is a highly technical area, carbon accounting in forests, and you can certainly go down a rabbit warren, but there is these links will help you out a lot. FullCAM is the full carbon accounting model, which you can, that's a direct link to the software. It doesn't run on iOS, so you can download that software and you can actually try and have a play. But I would, unless you're particularly, adept and interested in that, it's a very complicated program to learn how to run. A much simpler one to see how carbon gets generated in the landscape is to use the Look-See tool, which is the second link down there. And the Look-See tool is a geographic-based area, again, that uses the FullCAM data. And so you can go anywhere in Australia. You can find your own, a farm that you might know, one of your neighbours' farms, or you're not, if you haven't got any neighbours that have farms, you just can go anywhere in Australia and you can click an area and you can see how many ACCUs or carbon credits it generates. That's very easy to use, that tool. So I highly recommend you go and have a look at that tool and have a play with that, because you'll see what different areas produce in terms of carbon. So the next link is the old National Carbon Accounting System. Now, this is an absolute gold link. This is very hard to find online. So definitely have a look at that link. It's got all the original carbon accounting system documents and files going back 20, 25 years. And that is very hard to find. And most people don't realise that back in 1999, Australia was going to be the first country in the world with an emissions trading scheme. And we had this big government office called the Australian Greenhouse Office that pioneered all these NCAS technical documents. So we were some of the leading science, we had some of the leading science and reports in the world 20 odd years ago. And we were 6 weeks away from commencing an emissions trading scheme in 1999. I actually met the person that was going to run it, and unfortunately that whole architecture got pulled out by the government of the day after a delegation, unfortunately, of fossil fuel companies went and saw the government and expressed displeasure of the emissions trading scheme. And I don't have to tell any of you what's happened ever since. Native Conifers Carbon Sink, you can have a look at our project if you'd like there. The Clean Energy Regulator, that's the ERF, is the Emissions Reduction Fund, which is the main carbon purchasing arrangement that the government has in place. So you should go and have a look at that. And that includes a whole bunch of information and data about how many carbon credits have been generated. For your information, just last week, the 100th millionth carbon credit was issued in Australia. So 100 million tonnes of carbon have been abated or avoided or sequestered since the scheme started. And there's been over 1,000 projects now registered all over Australia. And that Clean Energy Regulator site has a map on it where you can go and look at all the different projects, and it shows you where they are. And the bottom one is Farm Forest Line, which is some those earlier examples I had about how to measure standing tree volume are on that particular link there too. So you can go back and have a bit of a play there too. So some really good links there. And I'd like to thank the opportunity for the Carbon Hub, who I am involved with Genia, and also like to thank University of Queensland, and I hope all of you have learned something today. If you have any questions, you can get in contact with me through our Native Conifers website, or Genia has my details. Thank you very much.
Thank you, Darryl. That was a really great presentation. And we look forward to also hearing from you soon on savanna burning. So thanks again.
No worries. Thank you.